Hello everyone. Today let's solve the problem number 705. Design hash set. Right. So this is the design problem basically. So what we are asked to design basically here, design a design a my hash set class to support these operations efficiently. We have to design the my hash set class to support these operations efficiently. What are the operations here? Add, this one, remove and contains key, add key, remove key, and the contains key. So these are the operations, right? So we have to design the my hash set class to support these operations efficiently. What are the operations again? Add key, remove key, and the contains key. Without using built-in hash set or hash map classes, we should not use without I mean we should not use hash set or the hash map built-in classes. Just keep this in mind, this is very important. And keys range from 0 to 10 to the power of 6, and operations must be less than or equal to 10 to the power of 4. So see here the constraints I'm speaking of here. 0 less than or equal to key less than or equal to 10 to the power of 6 they have given here. So keys ranges from 0 to 10 to the power of 6, and operations here at most 10 to the power of 4 calls will be made to add, remove, or contains they have given. Nothing but operations less than or equal to 10 to the power of 4. Right. So this is what the question states here. Right. So one more thing that we need to observe here is, so here we have my hash set, this one method, add method, remove method, and the contains method. Here my hash set is nothing but the initialization part. So add, the return value of the add and remove will be null as well. Right. So the return value of the my hash set, add and remove, these three things will be null. And only the return value of the contains is this one, number, right? Sorry, boolean value, either true or false. So the return value of the remove, add, and my hash set will be always null, and only the return value of the contains will be boolean value, either true or false. Right. So what shall we do first? Let's discuss the approach accordingly with the question. Let's come to the first example here. So just give me a second here. One second. So here we have my hash set of empty. So this one, this has to give us the null basically, right? So this is fine. So next what we have, add of 1. Sorry, just give me a second. What happened here? Yeah, add of, so we have add of 1 here, right? So we have successfully added 1 to the hash set, right? So next, this is completed as well. Next we have add of 2. So we are adding 2 to the hash set. This is fine, right? So this is also fine. Next we are checking whether contains 2, this one. So basically this you cannot see here, this I have given, this is nothing but 2 here. So yeah, we have 2 in the hash set. So this one we have to get the value true. In this case, for the first 3 we got null. For this one, contains of 2, yes, only the contents, as I've said earlier, only the contents, return value of the contents will be boolean value, either it will be true or false here in this case, right? So here contains of 2, yes, 2 is in the hash set here, this one I'm speaking of. So we have to get the we have to return the output true here in this case. So again we'll be going with the contents, so the return value will be boolean value, so either it will be true or the false. Contains 3, here we have only 1 and 2 in the hash set, we don't have 3 at all, so this will be false in this case. No, it does not contain 3 here. Next we will go with add. So the return value of the add is null, we know, so we will be adding 2 to the this one, hash set, I mean, yeah, hash set. So here we already have the 2, we don't have to worry about 2, we already have the 2, we don't have to worry about. So 2, we have 1 and 2 in the hash set, we already have 2, so we don't have to worry about 2. Next what we will do, we have contains of this one, what we call 2. Yeah, contains of 2 will be quite obviously true here in this case, right? So contains of 2 will be quite obviously true. Yeah, we have 2 in the hash set right here. So we have 1 and 2 in the hash set. So we have 2 in the hash set. This is fine. Next, what we will do, remove. Remove of 2 they have given here. So we have 2 in the hash set. We will be removing the this one. What do we call? We will remove the 2 from the hash set. Now the return value of the remove is still null. So we will go with null. Only the return value of the contains is boolean value, right? Either true or false. Again, the final one is contains. Contains of 2 they have given here. So we have removed this one from the hash set 2. Now we have only 1 in the hash set, right? Now we have only 1 in the hash set. So contains of 2, no, 2 is not present in the hash set. So we will return false in this case. So this is how we got the output null, 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 true, false, null, true, null, and false. In the explanation part also they have given the same thing, right? So in the explanation part also they have given the same thing. I hope whatever the example or whatever the approach that we discussed is completely clear. Easy to understand, right? Very easy to understand, right? So I hope the question part is completely clear, and I hope the approach part is completely clear as well. So what will be the time complexity and the space complexity for the code that we will be writing basically? So here the time complexity would be, just give me a second here, 1 second. So the time complexity would be big O of 1. Why the time complexity is big of 1? For each operation I'm speaking of, whether it may be hash set, whether it may be add, whether it may be remove, or whether it may be contains. For each operation, the time complexity would be big O of 1. Why? Because we are speaking of the direct array access. Direct array access means we are going with the direct array access, right? So this will be constant time. So again, I'm telling here. So the time complexity will be big of 1. Why it is big of 1 here? For each operation I'm speaking of, we are going with a direct array access, right? So it will be constant time. So the time complexity will be big of 1 for each operation. And what will be the space complexity here? The space complexity will be big O of this value 1, 0, 0, 0, and 0, 0, 1. This one, this is fine. So this is fixed boolean array we are making use of to hold the all possible keys. As the time as the constraints we have been given as key less than or equal to 10 to the power of 6 and operations less than or equal to 10 to the power of 4. This is the size of the array that we'll be going with. So this is fixed size boolean array to hold all the possible keys. Just keep this in mind, right? So this is the time complexity and the space complexity of the code that we'll be writing. So first thing, let's do one thing. Let's start writing the code. So as I've said, this is the initialization part, and the return value of the add and remove is always null. We know this one, and only the return value of the contains is either true or false. Boolean value true or false. We know this one, right? Now let's do one thing. Let's start writing the code. First thing here is uh, we need boolean array representing the hash set, right? Also index, we have to assign the index to the key. Let's do one thing here. So I'll just go with private boolean this one set. This is fine. So and also let's make use of the constructor to initialize the boolean array. We have to initialize the boolean array, right? So for that one we'll be making use of the constructor. So I'll just go with public my hash set. So this is fine. So within this one, within the constructor, we need the keys from 0 to 10 to the power of 6. So let me assign set to new boolean of, so size we have already discussed this one, why we are making use of this size, right? So we need keys from 0 to 10 to the power of 6, right? So I can just write in this way 1, right? So this is the size we will be making use of. So we have already discussed this one in the space complexity as well, right? So I hope this is completely clear. So after this part, what we will be doing, uh let's do one thing. Mm, so this one we don't want, I think, public. So we can just go with direct class my hash set we are going with, right? So this one we don't need, I think. So this is fine. So let me format the code once. Yeah. And within this one, add method, what shall we do? We just have to add the key to the set by setting the index to true. So I can just write this one in the simple way. Set of key, this one will be true. right? So this is fine. So this has to be in the array. Yeah, this is fine. So the next method is remove. So what we will be doing in the remove, so basically we need to remove the key from the set by setting the index to false. Initially for the add method we were adding the key to the set by setting the index to true. Here we will be setting the index to false. We have to remove the key, right? That is the reason we'll be setting the index to false. So here I'll give set of key equals false. So this is fine. The final one here is this one, contains method. So we have to return true only if the key exists, right? Key exists in the hash set. If the key is not existing in the hash set, then we have to return false. So I'll just give here return set of key. So this is it. So let me format the code once and let me hit the run button. So here we have the compile error. Let's see. Yeah, I have missed the semicolon here. So let me hit the run button again. Again we have compile error, line number 10, right? So I'll just, yeah, we have to give the semicolon again. So let me hit the run button again. So here you can clearly see the sample test case is getting passed. So let me hit the submit button. So here you can clearly see all the test cases are getting passed. So I hope the solution part is completely clear. For now, this is it. Thanks for watching, guys.